Okay, paper 2, question 8. We're going to set a calculator page, and the first part is asking us to how many groups of 5 can be selected. Well, we're choosing 5 from 12, so if we do menu, probability, combinations, and do 12C5 effectively, we get 792. Now for parts B and C, instead of actually doing the question, we're going to just run a little simulation showing how you can use the Inspire to help you explore ideas like this particular question. So we need to set up the 12 people. So what I'm going to do is I'm going to define a list called people, spelt correctly. I'm going to define that as equal to, so control divide, and then control curly brackets, so that's right bracket, and I'm going to type in 12 symbols to represent the 5 males and the 7 females. So the 5 males I'm going to give all to be the value of 1, and the females all to be the value of 0.1. So that's 2, 3, 4, 5, 6, and 7. So there are all my 12 people, 5 males and 7 females. Now I'm going to try and take groups of 5 from this little sample, and the way we can do about that is if I press catalog, there's the command randsump, and it wants to know the list, the number of trials you're going to take, and whether to replace or not. And so what we're going to do is we're going to use that command, randsump, and we're going to use the list called people, so variable people. We're going to pick 5, and we don't want to have a replacement, so we'll do the number 1. And so when I do that, it randomly picks 5 people. I seem to have a female, a male, and a female. Now you'll see why I chose 1s and 0.1s in a moment. Let's just run that command again, and I get a different selection of people, seemingly 3 males and 2 females. Now the quickest way to see what we've got is if we just use the sum command, sum, and I'm just going to paste in that command there, and so I can see that all the 1s will be males and all the decimal 0.1s will be females. So in this particular random sample, I got 1 male and 4 females. If I press it again, I got 2 males and 3 females. 2 males, 3 females, and so on. It's generating lots of 2 males and 3 females. Then we're back to 1 and 4, 2 and 3, and 3 and 2. So this is a good way of running lots and lots of different selections. Now what I'm going to do is I'm going to repeat this process lots and lots of times. I'm going to do a sequence of all these experiments. I'm going to just put a dummy variable of n in, and I'm going to run it from 1 to 100. I'm going to run 100 samples of size 5 from this collection of 12 people. When I press enter, I get a big long list, and you can see there's 3.2s, 1.4s, all the full mixture in there. And so therefore what I want to do is basically see if I can capture all these values and plot them on a graph. So let's go and call it results, and I'll press Control Template to paste in that command, and when I run it again I will have run another 100 trials, but all those 100 trials I've remembered in the list called results. So what I can do is I can go to a new page, Control Doc, and Data and Statistics. There are all my 100 results there to some extent. I'm going to now look at results, and you can start to see that in this situation there were no males and 5 females. We didn't have a situation where there was 1 male and no females, because we've got 1 male and 4 females. That's what these numbers there are. 2 males, 3 females, 3 males. We haven't got 5 males and no females. Now the question was asking probably that no men are selected. Well, no men selected would be down there. We've got 2 out of 100. Now obviously that may not necessarily be the case if we run it enough times. I'm just going to go to a see if I can look at this information, so it will give me decimals frequency. And so what I'm going to do is I'm going to go down, I'm going to press Control Menu, and I'm going to force this to be a categorical values. And that allows me then to go into empty space and do a pie chart. And you can start to see that the no males and 5 females had 2% of the time. Now, that was just for a 1 over 100. If I go back to my calculator page and run another 100, all of the probabilities change slightly. Now I've got 3 cases, so about 3%. And it will change as every time you run this experiment. So what I'm going to do is I'm just going to run it a large number of times. I'm going to run it 1,000 times. It'll take a wee while on a handheld. But again, we go back to the display here, and it seems as if I've got 31 cases out of 1,000, around about 0.31%. Now, when you do the exact calculation, you get 0.265, and I've got 0.31 here, and so therefore we've got a comparable value coming in. So this is just a simulation, it's not actually doing the calculation for us. But when we're being asked probability that 2 men and 3 women, we're looking at this group here, 2 men and 3 women, and that's coming in around about 0.41, and the actual answer is 0.442. So again, very similar. And to some extent, this just reinforces that probabilities are approximations, and it's only seeing what happens in the long run when things really start to show themselves. Just because we can, let's just increase the sample size yet more. Let's go to 2,000. This will be very slow in a handheld, but we've now got answers which are slightly closer or slightly further away, depending how you look at them, to the values that are the correct decimal solutions. So, nice way of simulating an experiment. We're done.